Okay, so the next number, this question is also a typical pigeonhole principle question. And so sometimes the companies like Wall Street financial companies, they have these kind of interview questions. Okay, so you need to be, if you want to do the quantitative analyst, you have to be good at math. So this is one of the possible interview questions. They ask you this, right, on the phone or in person. They ask you this, right? So let's see. Assuming there are 101 Dalmatians, those are dogs. Okay, Dalmatians are like white dogs with black spots on them, right? So each dog has some finite number of spots. Right, the spots could be 0. It's completely white. Okay, that's a rare, but okay. So we just assume it could be, and it could be 1 spot and 2 spots and total number of spots, any number, right? So show that it is possible to choose 11 of them whose total number of spots is divisible by 11. Okay, so let's see. Let's see what's the scenario here. We try to do pigeonhole principle. In this case, the pigeonhole principle is considered like this. We are putting these 101 dogs into, or we say we tie them up into the different fire hydrants or something like that. Okay, we tie them into with leashes. Okay, we tie them into the fire hydrants or separate them. How do we separate them, right? Of course, we're talking about divisible by 11, and by all these previous examples, we think this is a question about mod 11. Right, this is a question about mod 11. So in mod 11, we have how many possible values? 1, 0, 1, 2, up to 10. There are 11 values. Okay, so we want to put these 101 Dalmatians into 11 possible, well, as I said, we tie them into 11 possible fire hydrants or something, okay, or trees, okay. So it's basically every fire hydrant or every tree, the number of spots of those dogs should be the same remainder mod 11, right? So we should tie them this way, and then the problem here is if we divide them up in like that, and say we have 11, let me say trees, okay, tie them to trees, 11 trees, and then 100 divided by 11. 100 divided by 11, the value is 9. Okay, 9. At least for okay, let's say each tree on average has 9 of them, 9 dogs, and some tree have to have 10 dogs, right? Because it's 101 is more than 9 times 11. 9 times 11, 99. Right? So that's the more, 2 more, but you can't say that you have 11, right? So you have one of the tree has 11. It could be the two actual ones or divided into 2 trees, okay? So each tree has 10. So in this case, we cannot say, okay, okay, one of them is 10 dogs, and then we take all those 10 dogs. But then we're trying to choose 11, and also we try to add up the spots to make it divisible by 11. So the good case is, what if we have 11 dogs tied to 1 tree, right? If we have 11 dogs tied to 1 tree, then we can actually just pick those 11, and then because they have same remainder mod 11, we add up those numbers. That's going to be multiple 11. Okay, so that's a good case. But in this case, like I said, 11 separate into 101 separate into 11 trees. It's not going to work, right? It's not going to work because you divide them too much. So let's be more careful, okay? Let's be more careful looking at these options. Suppose these 11 trees, each tree has some dogs tied to it, okay? So some dogs have 0. 0 doesn't mean 0 spots. It could mean 11 spots, okay? 0 mod 11. So those dogs, we pick one of those dogs. And then how about 1 mod 11? We also pick one of those dogs. And because we know that every tree has at least 1 dog there, so we just pick one from each tree. Pick 1 dog from each tree. The number of spots in that case, okay? So the number of spots in that case will be 0, 1, 2, 3, up to 10 mod 11. If we add them up, 0 plus 1 plus 2, up to 10. You add up those numbers, then the answer is 55. Okay, the number 55 is the multiple 11. So this is a good case, right? So if every tree has a dog or more dogs, we pick one from each tree. And then we have our what we want, right? 55 mod 11, which is multiple 11. Okay, so the bad case is, what if one of the trees is empty? So we can't do this anymore, okay? If one of the trees is empty, so that's another case, right? One of the trees is empty, then what we have is that all the 101 dogs are tied to the remaining 10 trees. That is a situation we want, right? So 101 dogs tied to 10 trees. And then 101 divided by 10, that's a 10 and with the remainder 1. Okay, so that means we could tie 10 dogs for each tree, but one of the trees has to have 1 more because we have, it's 101 is 1 more than 10 times 10. Okay, so 10 trees tie 101 Dalmatians. One of the trees has to have 11 or more. That is the situation we want, right? We choose those 11, and then what happens is you add those numbers up. You add those numbers up. That sum is a multiple of 11, and then we're done. Okay, so 2 cases. 1 case is 1 dog, we take 1 dog from every tree, then the sum is 55, which is multiple 11. That's good. Another case, if we don't have 1 dog from every tree, we have 1 empty tree. So in that case, we have we can actually have 1 tree with 11 dogs or more. So that we take those 11 and we're done also. Okay, that's a proof of this